Welcome to qnawire.
So we're told that f and g are both twice differentiable and also that they are concave up on this interval, so on the interval I. And what we want to find, or what we want to show, I guess, is that f plus g is also concave up on this interval. And so the way that we're going to do that is we know that f plus g is just the summation of these two functions. So the derivative of f plus g, well, when we find the derivative of some function plus another function, that's just equal to the derivative of the first plus the derivative of the second. So this is just equal to f prime plus g prime. And then if we were to do this again, let's just say f prime plus g prime, and then we found these next derivative, which would be our second derivative. This would just be equal to f double prime plus g double prime. And since we know that f double prime and g double prime are both going to be positive, since we're concave up on this interval, that means that f plus g, the second derivative of f plus g, is also going to be positive, which means that we're going to be concave up for the function f plus g as well. So since our second derivative of f plus g is greater than 0, f plus g is concave up. And for part B, what we're going to do is we're going to show that if some function f is positive and concave up, so we're going to say f is positive, and I'm going to denote concave up as cu on the interval I, then we need to show that this function g of x, which is just equal to our function f of x squared, we need to show that that is also concave up on the interval I, or L. It might be L actually. But so if we go ahead and do this, what we're going to need to do is find the first derivative of g of x. And so we're just going to use the chain rule to find this. So we need to bring down this 2 first. So we bring down the 2. We have 2 times f of x to now 2 times 1, or 2 minus 1, which is to the first. And then we have to multiply by the derivative of f of x. So we have to use the chain rule here and multiply by the derivative of f of x after we bring down this exponent. And so now that we found this first derivative, what we're going to do is find the second derivative, which is going to be using the product rule. So we're going to do the derivative of the first. So we have 2 times f prime of x times the second, which is also f prime of x, so this is f prime of x squared, plus the first, which is just f of x, times the derivative of the second, which would be f prime, or f double prime of x. So if we simplify this, this is equal to 2 times f prime of x squared plus f of x times f prime, or f double prime of x, and then this is also multiplied by 2. I forgot the 2. So if we look at this second derivative of g of x, this term here is 2, which is positive, times some number. Our f prime of x is just going to be some number squared, and any number squared is going to be positive. So this is going to be a positive number. 2 times f prime of x squared, this is going to be a positive number, since we don't have any i's or imaginary numbers in our domain. And now if we look at this second derivative, or the second term in our second derivative, we know f of x is positive. We were told f of x is positive on this interval. And we also know that f of x is concave up on this interval. So we know that its second derivative is also going to be positive. So this term is going to be 2 times a positive number, since f of x is positive, and then times another positive number, since we're concave up. So this is going to be equal to a positive number plus a positive number, which means that g prime, or g double prime of x, is going to be greater than 0 on the interval I, which means that g double prime of x is concave up.